I found this diagram when I was looking for rock cycles, and I put it in the extra PowerPoint that I uploaded, but we're not going to use this one. I just wanted to put it in here because I think it is absolutely wonderful. This diagram has absolutely everything on it. Of course, that can be a problem when you're trying to first digest. So we're not going to go here. I just wanted to put it up because this... Okay, so this is probably a much more user-friendly diagram, much easier to digest what's on here. And it'll work for what we have here. So we're going to talk through all the different points on here, and I want to talk about what we're doing here. So you have your igneous rocks, sedimentary rocks, and metamorphic rocks. So those are our cornerstones, and then we are going to add magma and sediment here. But then these arrows, all the arrows are process arrows. So there is a process going from magma to igneous rock. We're going to talk through those. There's a process going from sediment to sedimentary rock. And that brings up a couple of things that I did want to change on this diagram. So they talk about compaction and cementing, and I want to use a more general term. This will add to your vocabulary in geology, is a term called diagenesis, and that is becoming rock. So compaction and cementation are parts of the process, but they're not the only way that it can happen. So we're gonna call it diagenesis as a whole. And then similarly, this uses crystallization up here, and I want to use the term solidification. All right, so it's a circular diagram, it's a cycle, so we could start it anywhere. I want to start from magma. So let's consider a starting point of having this molten rock, which is what magma is. Notice I do use the term magma instead of lava. The difference is just whether or not it got out on the surface. Magma that gets out onto the surface is called lava. All right, so, and then we have a process, and this is the one I wanted to call solidification instead of crystallization. So we have a process going from this molten rock. It's basically going to freeze, just like you would put liquid water into a freezer and freeze it into a solid form. That is the process of magma freezing into an igneous rock. So down here you'll see my note that I'm using freeze or solidify instead of crystallize, because there are some forms of igneous rocks that are not crystalline. For instance, obsidian. Obsidian is an igneous rock that is glass. It is not a mineral. It is a naturally occurring glass. It has no crystals. Well, it is not crystalline in that at least you can't say that it is predominantly crystalline. Occasionally you can find a few in there, which are really neat to see with the crystobolites and stuff. But it doesn't have to be a crystal to be a rock, to be an igneous rock. Now later when we get to minerals, it would have to be crystalline to count as a mineral. All right, so freezing of magma becomes igneous rock. Okay, here's that graphic organizer I was talking about, and it is, I did upload a PDF of it in the course, so you can grab that and print it. You can screen capture this guy. Let me get the red little pointer out of the way. You can screen capture this guy if you want to do that. However you want to do it. Later on I'm going to want you to upload it. I made you one in a PDF already. I want you to start filling it in. So this guy here is going to be minerals, and they make rocks as a whole, right? And then we're going to start to break out the different, I don't remember why these two are different, but we're going to start to break out igneous rocks, sedimentary rocks, and metamorphic rocks. And then we're going to talk about the different types of. And actually, if you watch this YouTube video that I've linked here, I think this link only goes through the igneous, but then you can get to the others right there from it. Okay, so we're at igneous rock. We got there by freezing a magma into igneous rock. All right, so we have this igneous rock. Let's say it's a basalt. What could happen to it? Well, igneous rocks could get exposed to the surface and weather away, into sediments, into sand, silt, or clay. So the weathering process would be this blue arrow here, weathering. Or it could get buried deep in the earth or otherwise exposed to extreme pressure and temperature, and it can be metamorphosed. So this is a process arrow, so something is happening. The process is called metamorphism or metamorphosis, and it changes a rock, in this case igneous, into a metamorphic rock. What else could happen? Well, you could remelt it. So you could freeze magma into an igneous rock, but then you can melt it. Okay, choosing one of those directions. Now, in the last slide we had 3 different places that the igneous rock could go. Then let's just take the weathering to sediment. So remember, this is a process. The blue arrow is weathering to sediment. What could happen to sediment when you have it? Well, so you can take this sediment and you can bury it, right? And you can squash it down. I know that's a very technical term, right? You can bury it and put it under pressure, and sometimes chemical change conditions, different things to cause it to undergo that process that I called diagenesis back in the early slides, second last thing, third maybe, and cause it to become a sedimentary rock. Okay, so let's talk about sediment versus sedimentary rock. So just picture in your mind that you have a shovel full of sand. Okay? Now also picture in your mind a separate shovel full of sedimentary rock. And you can kind of see the difference between a shovel full of sand or a shovel full of chunks of sandstone. And you see the difference between sediment and sedimentary rock. So this diagram doesn't have anything from a sediment other than going to sedimentary rock, and I think there's an interesting question of whether you could do other stuff to it, like melt it or something like that, but we can avoid some of the more detail. And here again, here is a link to, see if I can highlight that, a link to the YouTube video, and if you're watching this on my YouTube videos, I guess you can either try to type that in, or it's probably easier to go to the PowerPoints and grab it out of that. I don't know, whichever way is easier for you, but then watch through the sedimentary one. I would note again that I have some differences with his take on this. Chemical sedimentary rock, I don't like that term. I'm sorry, let me say that backwards. I do like chemical sedimentary as opposed to his crystalline sedimentary rock. The crystalline rock is a term that geologists sometimes use, maybe unfortunately, but sometimes use for metamorphic rocks, and so I want to avoid that. Chemical sedimentary rock is pretty much what he refers to. When we get to sedimentary rocks, I'm going to talk deeper about the biosedimentary rocks and stuff like that, like limestone. But for now, you can use either term that you want. I just want you to start. Okay, so now we are at our sedimentary rock, right? And let's talk about process again, process arrows. So what could happen to my sedimentary rock? That sandstone that we had earlier, or a limestone, what could happen to it? So the same things can happen to the sedimentary rock that could happen back here to my igneous rock, right? What did we do with it? We weathered it, we metamorphosed it, or we melted it. Well, sedimentary rocks, you can weather again. So you can have a sandstone, and then you can expose it and weather it back to sand again. If you've ever spent any time up on Sand Mountain, you can see it on top of Lookout as well. You see the sandstone units, the Pennsylvania aged sandstone units there, weathering back into sand as a sediment again. So we could weather it, we could put it into those metamorphic conditions, the intense heat and pressure again, and metamorphose it into a metamorphic rock. Or we could push it down into a zone where it gets too hot to just metamorphose and it actually melts into a magma again. And so we're back to where we started with a magma. So that could happen to our sedimentary. And here's your link to the metamorphic rocks video. And his usage of metamorphosize, I don't know why that bothers me so much. I don't suppose there's anything actually wrong with it. It's not the way I usually hear it, metamorphose. So it's not like I'm gonna get very upset about you using metamorphosize. It just seems a little much. And then one last slide here to talk about metamorphic rocks. So with the other rocks, we talked about what could happen to them. So what do you think might be possible to happen to metamorphic rocks? Well, it's exactly the same answer yet again. So what could we do with our metamorphic rock? We could weather it away into sediments, same thing, and then those sediments get reused into something else. That's kind of an important one that he left off. Metamorphic rock can be re-metamorphosed, and actually this is fairly likely to happen because when you metamorphose something, a couple of things happen. First, you've put it in the conditions for metamorphism, so it's likely that it's going to hang out in those conditions and get re-metamorphosed. That's why those rocks are so complex and hard to interpret sometimes. Another thing that can happen is that you tend to make a rock that is a lot more resistant to weathering and other stuff. So these rocks hang around. Some of the oldest crust that we have on the planet is deeply, deeply metamorphosed, maybe multiple times, because it gets exposed at the surface and then stuff gets dumped on top of it. More sedimentary rock may form on top of it. It gets buried again, metamorphosed again. So it has probably undergone multiple iterations of metamorphosis. So that's an important part to keep with it. And then, of course, if you get it heated enough, you can even melt it back into a magma and start all over again. Remember that this thing is circular, so you could have started anywhere, and we would still gotten all the way around. You can short circuit it with these arrows in between. Let's see, what else? Remember that these are processes, the arrows in between, and the diagram that you're filling out to go with this is more about the characteristics of sedimentary rock, of metamorphic rock, and of igneous